So if you're one of those people that get distracted easy, make sure that you watch this in segments, so that way you're not just tuning out and then forgetting what I'm saying. So we're going to start with Chapter 2, Properties of Matter. So why are windows made of glass? That's a good question to ask, because why do we choose certain materials to make certain things? In this lesson, you're actually going to learn how properties, and we're going to define that, can be used to identify and classify matter. So why do we use certain things, for example, to build houses? Why do we use certain things inside computers to make technology work? We use certain things based on its properties. So what you observe when you look at something, any type of matter, so a desk, a window, a phone, what you observe about it are the properties. For example, is something a solid? Is it shiny? Is it dull? Or does it kind of have like a not so shiny appeal? If it's a liquid, does it flow quickly like water? Or is it very slow like syrup coming out of a bottle? If it's a gas, can you smell it? Is it odorless? Or does it have a distinct smell and you really like or hate that smell? So properties can be classified in different ways. The first way we're going to learn is how to classify them as extensive or intensive. And we're going to talk about those just a tad bit more. So hopefully you can use these examples. One thing I do before we get into it is to illustrate is that extensive is always going to depend on the amount, and that's going to be the definition, while intensive is going to depend on the type of matter you have. So here's the definition of extensive. An extensive property is a property that depends on the amount of matter that you have in a sample. So how much? So again, how much? Do you have a lot? A little? And two that we're going to talk about specifically in mass and volume are going to be extensive properties that depend on how much you have. So the mass of an object is the measure of the amount of matter it contains. So here, if you have something that there is a lot of it, so like a basketball, it's going to have a greater mass than if you have something that doesn't have as much mass in it, or the amount of matter. If I had 2 basketballs, my mass is going to be smaller than if I had 5 basketballs. So here, it depends how much I am holding or how much I have. The next example that they put on here for an extensive property is volume. And this is basically how much space does that object take up. The volume of a basketball is going to be greater than the volume of a golf ball. If I have a cabinet, it's going to be a lot harder to shove a basketball into a desk drawer than it would to be shoving a golf ball, because a golf ball takes up less space. Hopefully when you guys do move into your room or reorganize stuff, you are conscientious of the space things take up. Now, those are all extensive properties. However, there are other properties to consider if you're looking at something like a basketball, other than how much does it weigh and how much space does it take up. If you're a basketball player, there are actually different coverings for basketball. There are leather coverings that you see most often when you play inside. There's even rubber coverings, so those basketballs they sell for like outdoor play. You can think of something else besides basketball. Think of your clothes even. Some clothes are softer than others because some clothes are made up of cotton. Some of them are made up of polyester and wool. So clothes also have different, basically, materials. And each of those materials have different properties that make them suitable for different things. So those other things besides mass and volume can actually be classified as intensive if they fall under this definition. And basically, it's the property that depends on the type. So is it, for clothes, is it wool, cotton, polyester? And you don't necessarily have to care about the amount. You can have a small little shirt. You can have a huge shirt. No matter what, as long as it's made up of this type, It's an intensive. So for example, basketball's absorbency. Absorbency is basically how much water it can hold or particles it can take in. So we're looking at the basketball example. Leather balls are actually going to be suitable for indoor play and not outdoor. The reason is leather balls like to absorb a lot of water and dirt, and then those basketballs get really gross and disgusting and they start to smell, so we don't use them for outside. If you think of the example for clothing, instead of the adjective absorbency, we might use the adjective how soft is it, or its hardness. And you're going to notice that certain fabrics of your clothes are softer than others. So you might use certain clothes suitable for a wedding. You might wear different clothes if it's cold out, if it's warm out, etc. So up here, this is my first question I have up here to see if you kind of understand the difference between intensive and extensive. So you have extensive, and then you have intensive, and then you have to write down what you know about it. Intensive depends on the amount, whereas intensive depends on the type. So you want to compile a list of properties of a substance, but you don't have a way to measure the mass or volume. So think about that. Mass and volume, based on our notes, what did we classify them as? Extensive. Yep. What kind of properties can you determine without knowing the amount? Well, since extensive depends on the amount, I cannot know what the extensive properties are. So I'm looking at intensive. This brings us to our second part of this, which is a different way you can classify properties. You can classify them as physical or chemical. So we're going to hit physical, and this is actually very important for your lab tomorrow. So if you're one of those people, we're going to do a lab that illustrates physical properties. It is basically properties that you observe or measure, so you can look at it and weigh it, find out how long it is, without changing the composition. So without. And remember, composition is what it's made up of. So it's makeup. For example, is it hard? Can you hit it? Can you scratch it? What color is it? Red, blue, green. Conductivity has to do with electricity. So can it carry electricity? And is it malleable? So malleable is a term that you guys may not have heard it, but basically malleable tells me, can it bend? If you hit it with a hammer, is it going to shatter or is it just going to bend? So here's an example of some physical properties. You have whatever thing that we're looking at. We can say what state of matter that it is in, gas, liquid, solid. What color is it? And then even melting and boiling point, both of these are going to be considered physical properties. So physical properties can actually help identify substances, and this is what we're going to do in lab on Thursday and Friday, and hopefully we get it done, but if not, we can push that on to Tuesday as well. If you're given two different things that are colorless, and I tell you without looking at it to drink it, how do you know what it is? Well, some things that are clear are not going to hurt you, like water. Other things, if you drink them, they can affect you. So what you do is you have to test for the properties. And here what they did was they tested for the boiling and melting point. The first colorless liquid was 100 degrees Celsius and 0 degrees Celsius. If you remember from junior high, or if not, water is always going to boil at 100 and freeze at 0. So we can kind of guess that's probably water. If we test the other substance and it boils at 78 and melts at negative 117, we can say, okay, that's probably not water. So let's look at a chart and we can see that maybe according to a chart, it's ethanol. So over here, ethanol, 117 and 78. You have other things besides just physical properties. You also have something called a chemical property. And chemical property is based on the ability of a substance to do a chemical change. Is it able to change the composition? So a good example of this is the ability to rust is a chemical property. So when you rust, oxygen combines with iron and it creates like this reddish brown stuff, and you can see it on a lot of different metals like trucks, a rusty truck. Some other examples of chemical properties are reactivity. So how reactive is it with another compound? So can it react with something else? A good example I can use is when you were in junior high, even elementary school, you might have made a volcano with baking soda and vinegar. Well, baking soda has a high reactivity if it's mixed with vinegar, so that's chemical. And then you get bubbles and a new thing. Another example of a chemical property is going to be flammability. So, can it catch fire? So if something's highly flammable, a little tiny spark can cause it to burst up into flames. And whenever you catch something on fire, usually it is going to be a chemical property. So chemical properties, just like physical, can also be used to help identify substances, which is awesome. The only bad part is in order to examine a chemical property, it has to undergo that change. So if you catch something on fire, you lose that sample unless you decide to do a small piece of it. So here, glass is often used to make windows while copper is used for electrical wires. So what properties of glass are desirable material to use for windows? So this goes back to our opening question. Why do we use glass? Well, my number one purpose, or the property I noticed, is that it is clear or see-through. What's the point of a window if you can't see through it? I want to see the outside world. I want to let some sunshine in. Now, even though we allow windows to be open and we allow sunshine to come in, there is still some level of basically protection because windows do absorb heat. Yes, if you stand by a window, you can feel a little heat, but it's not as much as if you were to stand outside in the sunlight. Another good thing I like about windows is that they're durable. They can last a long time. They stand up against weather. So if it's raining, they're not just going to shatter. If it's thundering, things like that. And the last thing we have to talk about, or the third part of this lesson, is states of matter. The reason I put this in this section and the reason we're learning about the states of matter is because states of matter are always considered physical properties. So you can ask yourself, what are the 3 states of matter? Hopefully, you guys can tell me that one of the states of matter is solid, liquid, and gas. So we're going to take these 3 and kind of connect them to water. So if you have water, you can use 3 different words to describe it. Maybe it's just plain liquid water. So if it was in the liquid state. If it was frozen solid, it would be considered ice. So if it's in the solid phase. Or if it's in the gas phase, because you boiled it, you might consider it to be called steam. So water is one of those common things that can exist in all 3 states, liquid, solid, gas. So can a lot of other substances, actually. So again, those 3 states of matter are solid, liquid, and gas. So let's go into each of these. A solid is a form of matter that has a definite shape and volume, which means they cannot change their shape. And remember, volume is how much space it takes up. So no matter what, you can't take a table and put it in a circle and then the table become a circle. No matter what you do, a table is solid, it's going to keep that shape. It's also going to keep that same volume. You're not going to shrink that table down to become smaller because we're just not that magical. It's going to keep that same shape, and so you got to be careful where you can store it. The other thing about a solid is the particles are packed really tightly together. So here's one atom, here's two, here's three. And you can see there's really not space between them. And that is why a solid is actually a definite shape, because it can't change. There's no room for these particles to move to make a new shape. The other thing about a solid is they are incompressible, which means you cannot squeeze them to be smaller. So cannot squeeze to be smaller. So if you have a table, like I said before, you can't just take your hands and squeeze it and make it any smaller than it is without basically shaving off the wood. In addition, solid is also can expand, but it does only slightly. And when I mean expand, I mean gets bigger. So if you heat something, typically it gets bigger and bigger, like if you heat a balloon. However, if you do that to a solid, it likes to stay mostly its same shape. The next you have is a liquid. A liquid is a form of matter that has indefinite shape. And so that means it can change. It flows, yet it has a fixed volume. So the volume cannot change. So the particles in a liquid are in close contact with one another. However, they do have a little space here. So since they do have a little space, they can move around one another. So because the particles in a liquid are free to move around each other, that is why liquids like to take the shape of the container that they're in. So right now, this liquid is taking the shape of this Erlenmeyer flask. If you put water in a short, fat glass, it's going to take that shape of that glass. If you put it in a tall, skinny glass, it's going to take the shape of that glass. The only thing is that the volume doesn't change. So when you pick that glass that you put water in, you have to make sure it's going to carry all that liquid, or the liquid is going to basically spill over onto the counter. So again, the volume doesn't change, but the shape can. So this brings us to the volume of a liquid is fixed or constant. We just talked about that. And so the liquid is going to have indefinite shape, flows, and fixed volume. We've been talking about that. So let's talk about two new aspects of liquids. They are almost always incompressible. Means they cannot be squeezed smaller. If you take water in your hand and you try to cup it and squeeze it, the water is not going to make a smaller volume. It's going to keep that same volume and probably fall out of your hands. However, water is a little bit different than solids because when you do heat them, they do expand a little bit. In fact, if you put water, water is the opposite. If you put like soda and you heat it up, the bottle is going to keep getting bigger and bigger. Next, you have gas. Gas is something that takes both the shape of its container and the volume. So both shape and volume changes. Now, the reason is because you have little atoms, and look how much space is all around them. So these things can move around wherever they want. They're like, oh, I'm going to go over here. I'm going to go over here. And so they can change their shape. For example, if you put a gas in a balloon, if you put it in a star balloon, it's going to take the shape of a star. If you put it in a circle balloon, it's going to take the shape of a circle. The same thing with the volume. It can take up a little volume, or it can expand and take up a big amount of volume. So like a liquid, it can take the shape. However, unlike a liquid, the volume can change. So volume can change. When you're putting gas in something, you don't have to worry about it being big or small enough because gas volume can change. So the particles in a gas, again, like I said on the previous slide, are usually a lot farther apart. And because there's a lot of space there, you can easily compress them. So you can put them into smaller volumes. You've probably heard of compressed gas quite a bit. Air tanks. They take air and they basically compress it and make it fit into a tiny air tank. And then you guys can use that when you're scuba diving. This slide is on here because a lot of times people hear the word vapor and gas and they like to use them interchangeably. And what that means is if they mean to say gas, they might say vapor, and if they say vapor, they may mean gas, and they think there's no difference. However, there is a difference. The term gas is used for substances like oxygen that exist in a gaseous state at room temperature. So anything that is a gas at room temperature is going to actually be red on the periodic table if it's an element. For example, some things that are gases at room temperature are carbon monoxide, oxygen, nitrogen, things like that. A vapor is when something can be a gas. However, at room temperature, it is a liquid or a solid. So it's a liquid or solid at room temperature. So water, if you boil it and it becomes a gas, you wouldn't say, oh, water, gas water. It would be water vapor. So this is the last question. A substance in its state in which it takes the shape of its container, what state or states could it be? So let's look at our three states. You have a solid, liquid, gas. So solids keeps the shape because the shape cannot change. And then it keeps the volume. The volume does not change. If we go back and look at liquid, it can change shape, but it keeps the same volume because you can overrun a liquid. And then a gas can change its shape. Think of helium balloons. And it can change volume. So let's see which one this fits. A substance that takes the shape, so it can change shape. So this one cannot change shape. Liquid can, and gas can. So our answer is liquid and gas. So it could be a liquid or a gas. And that is the end of 2.1. So I know this was a little long. Chemistry does cover a lot of information. So if you ever get lost or stuck, make sure that you're asking me questions because I can slow down. I can also give you more practice. I can explain things in a different way. So if you're not understanding something, make sure that you ask me. I hope you have a good day.